In geometry, a hexagon is a six-sided polygon or sixgon. The total of the internal angles of any hexagon is 720 degrees. Regular hexagon. A regular hexagon is defined as a hexagon that is both equilateral and equiangular. It is bicentric, meaning that it is both cyclic and tangential. The common length of the sides equals the radius of the circumscribed circle, which equals times the apothem. All internal angles are 120 degrees. A regular hexagon has 6 rotational symmetries and 6 reflection symmetries, making up the dihedral group D6. The longest diagonals of a regular hexagon, connecting diametrically opposite vertices, are twice the length of one side. From this it can be seen that a triangle with a vertex at the center of the regular hexagon and sharing one side with the hexagon is equilateral, and that the regular hexagon can be partitioned into 6 equilateral triangles. Like squares and equilateral triangles, regular hexagons fit together without any gaps to tile the plane, and so are useful for constructing tessellations. The cells of a beehive honeycomb are hexagonal for this reason and because the shape makes efficient use of space and building materials. The Voronoi diagram of a regular triangular lattice is the honeycomb tessellation of hexagons. It is not usually considered a triambus, although it is equilateral. Parameters. The area of a regular hexagon of side length t is given by an alternative formula for the area as where the length d is the distance between the parallel sides, or the height of the hexagon when it sits on one side as base, or the diameter of the inscribed circle. Another alternative formula for the area if only the flat-to-flat distance, d, is known, is given by the area can also be found by the formulas and where a is the apothem and p is the perimeter. The regular hexagon fills the fraction of its circumscribed circle. The perimeter of a regular hexagon of side length t is 6t, its maximal diameter 2t, and its minimal diameter. If a regular hexagon has successive vertices a, b, c, d, e, f, and if p is any point on a circumscribing circle between b and c, then p plus pf equals par plus pb plus pc plus pd. Symmetry. The regular hexagon has DIH6 symmetry, order 12. There are 3 dihedral subgroups, DIH3, DIH2, and DIH1, and 4 cyclic subgroups, Z6, Z3, Z2, and Z1. These symmetries express 9 distinct symmetries of a regular hexagon. John Conway labels these by a letter and group order. R12 is full symmetry, and A1 is no symmetry. D6, a isogonal hexagon constructed by 4 mirrors can alternate long and short edges, and P6, an isotoxal hexagon constructed with equal edge lengths, but vertices alternating 2 different internal angles. These 2 forms are duals of each other and have half the symmetry order of the regular hexagon. The I4 forms are regular hexagons flattened or stretched along one symmetry direction. It can be seen as an elongated rhombus, while D2 and P2 can be seen as horizontally and vertically elongated kites. G2 hexagons, with opposite sides parallel, are also called hexagonal parallelogons. Each subgroup symmetry allows 1 or more degrees of freedom for irregular forms. Only the G6 subgroup has no degrees of freedom but can be seen as directed edges. Hexagons of symmetry G2, I4, and R12 as parallelogons can tessellate the Euclidean plane by translation. Other hexagon shapes can tile the plane with different orientations. Related polygons and tilings. A regular hexagon has Schläfler symbol 6. A regular hexagon is a part the regular hexagonal tiling 6-3, with 3 hexagonal around each vertex. A regular hexagon can also be created as a truncated equilateral triangle, with Schläfler symbol T3, seen with 2 types of edges. This form only has D3 symmetry. A truncated hexagon, T6, is an dodecagon, 12, alternating 2 types of edges. An alternated hexagon, H6, is an equilateral triangle. 3. A regular hexagon can be stellated with equilateral triangles on its edges, creating a hexagram. A regular hexagon can be dissected into 6 equilateral triangles by adding a center point. This pattern repeats within the regular triangular tiling. A regular hexagon can be extended into a regular dodecagon by adding alternating squares and equilateral triangles around it. This pattern repeats within the rhombitrahexagonal tiling. Hexagonal structures. From bees' honeycombs to the Giant's Causeway, hexagonal patterns are prevalent in nature due to their efficiency. In a hexagonal grid, each line is as short as it can possibly be if a large area is to be filled with the fewest number of hexagons. This means that honeycombs require less wax to construct and gain lots of strength under compression. Irregular hexagons with parallel opposite edges are called parallelogons and can also tile the plane by translation. In 3 dimensions, hexagonal prisms with parallel opposite faces are called parallelohedrons, and these can tessellate 3 space by translation. Tessellations by hexagons. In addition to the regular hexagon, which determines a unique tessellation of the plane, any irregular hexagon which satisfies the Conway criterion will tile the plane. Hexagon inscribed in a conic section. Pascal's theorem states that if an arbitrary hexagon is inscribed in any conic section, and pairs of opposite sides are extended until they meet, the 3 intersection points will lie on a straight line, the Pascal line, of that configuration. Cyclic hexagon. A Lemoine hexagon is a cyclic hexagon with vertices given by the 6 intersections of the edges of a triangle and the 3 lines that are parallel to the edges that pass through its symmedian point. If, for each side of a cyclic hexagon, the adjacent sides are extended to their intersection, forming a triangle exterior to the given side, then the segments connecting the circumcenters of opposite triangles are concurrent. If a hexagon has vertices on the circumcircle of an acute triangle at the 6 points where the extended altitudes of the triangle meet the circumcircle, then the area of the hexagon is twice the area of the triangle. Hexagon tangential to a conic section. Let ABCDEF be a hexagon formed by 6 tangent lines of a conic section. Then Bryantian's theorem states that the 3 main diagonals AD, B, and CF intersect at a single point. In a hexagon that is tangential to a circle and that has consecutive sides A, B, C, D, E, and F. Equilateral triangles on the sides of an arbitrary hexagon. If an equilateral triangle is constructed externally on each side of any hexagon, then the midpoints of the segments connecting the centroids of opposite triangles form another equilateral triangle. Convex equilateral hexagon. A principal diagonal of a hexagon is a diagonal which divides the hexagon into quadrilaterals. In any convex equilateral hexagon with common side A, there exists a principal diagonal D1 such that and a principal diagonal D2 such that Petrie polygons. The regular hexagon is the Petrie polygon for these regular, uniform and dual polyhedra and polytopes, shown in these skew orthogonal projections. Polyhedra with hexagons. There is no Platonic solid made of only regular hexagons, because the hexagons tessellate, not allowing the result to fold up. The Archimedean solids with some hexagonal faces are the truncated tetrahedron, truncated octahedron, truncated icosahedron, truncated cuboctahedron, and the truncated icosododecahedron. These hexagons can be considered truncated triangles, with Coxeter diagrams of the foreman. There are other symmetry polyhedra with stretched or flattened hexagons, like these Goldberg polyhedron G. There are also 9 Johnson solids with regular hexagons, regular and uniform tilings with hexagons, natural and human-made. The ideal crystalline structure of graphene is a hexagonal grid, assembled DELT mirror segments. A beehive honeycomb. The scutes of a turtle's carapace. North Polar Hexagonal Cloud feature on Saturn, discovered by Voyager 1 and confirmed in 2006 by Cassini. Micrograph of a snowflake. Benzene, the simplest aromatic compound with hexagonal shape. Hexagonal order of bubbles in a foam. Crystal structure of a molecular hexagon composed of hexagonal aromatic rings reported by Mullen and co-workers in Chem. EUR. J. 2000, 1834–1839. Naturally formed basalt columns from Giant's Causeway in Northern Ireland. Large masses must cool slowly to form a polygonal fracture pattern. An aerial view of Fort Jefferson in Dry Tortugas National Park. The James Webb Space Telescope mirror is composed of 18 hexagonal segments. Metropolitan France has a vaguely hexagonal shape. In French, hexagon refers to the European mainland of France, aka the métropole, as opposed to the overseas territories such as Guadeloupe, Martinique, or French Guiana. Hexagonal hanksite crystal, one of many hexagonal crystal system minerals. Hexagonal barn. The Hexagon, a hexagonal theatre in Reading, Berkshire. Vladislav Glenski's hexagonal chess. Asian Pavilion.jpg